Hi, today I'm going to be showing you guys all about Boolean algebra. There are two parts of Boolean algebra, a Boolean and an algebra. Well, first, what is a Boolean? Well, a Boolean is just something that is either true or false. Pretty simple. Now, we can represent this as either a T for true or a 1. And for false, we can have either an F or a 0. And the algebra part is basically just doing stuff. There are three operations that you can do. You can have a not, an or an and. First, let's do the not. So a not just has one input. Let's say that that input is A. And what you're going to get out is one output. Let's say it's X. So A has two possibilities. It can either be a 0 or a 1. Pretty simple. And because we get the opposite out, if we put a 0 in X, we're going to get a 1. And if we put a 1 in, we're going to get a 0. So remember, this here, this is our input. And this here, just remember, is our output. Now, we need a symbol to represent this. So, for a symbol, what we use is either a little bracket in front, or a bar, or a tick, or a slash. Now, these two, I use these by far the most often because I think they're the easiest to read and the easiest to write. This slash here, this is mostly used for computers. This is very useful when you're like typing into messages to your friends and whatnot. And this tick here, I don't use it that often. It's a bit harder to read in my opinion, but if you like it, you can use it. Now, the or. An or has two inputs. So on the left side, we're going to have A and B. And on the right side, we are going to have our X. So remember, these two are our inputs, and our X is still our output. So there are four different possibilities if you have two inputs that can be either 1 or a 0. So we have a 0, 0, a 0, 1, 1, 0, or 1, 1. Now, what is the definition of or? Remember, it's if either of them are true. So that means that if either the first one or the second one, A or B, are true, then X is going to be true. So here in this first one, neither are true, so therefore X is false. And here, B is true, so therefore it's true. A is true in the next one, so it's true. And finally, both of them are true, and because either are true, that's true. Now, what's the symbol for this? It is just simply A plus B, but we read it as A ORed with B. Now for the AND gate, this is also a two-input gate, so we have A and B and our output is X. Now we have four possibilities again, either a 0 and a 0, 0 and a 1, 1 and a 0, or a 1 and a 1. Now, AND is only true when both of them are true. Therefore, 1 and 1, that's the only place it's going to be true, because that's the only place where A is true and B is true at the same time. And all the rest of these are going to be 0, false, because only one or none of them is true. Now the symbol for this is either going to be A times B, or A and B together with no symbol. And this here is the one you're going to see the most often. Now, how can we combine these? Well, we can say that, let's say we've got a two-input function. Let's just call it f, and we put in A and B. Well, we can say that it is equal to A, B, and we're going to OR it with, let's say, A not, and all of this in parentheses, let's say that is going to go with B not. Nice. Let's say we have another one. Let's call it G. And let's say this is 3. A, B, and C. Well, let's do A and B, and let's OR it with, let's do B not C. And finally, let's AND it all with C. Sounds good. Now, how can we see where this is true and false? Well, let's just plug it in. So we have A and B, and finally F here. So let's make the truth table. And let's figure out when these are true and false. So if we have 0, 0 here, so let's just do this. We're going to plug everything in. So we've got 0, 0 plus 0 naught, and we're going to AND this with 0 naught. Well, this will just be a 0 here, because if we look back at our truth table, we see that A and B, when they're both 0, we get a 0 here. So that's going to be a 0. Then not 0, well, that's going to be a 1, because if we look at our 0 in our not table, we're going to have a 1. And finally, the same thing again, we have 0 knotted, so we're going to have a 1. Now, 0 ORed with 1, well, 0 or 1, that's going to be a 1 here. We're going to AND that with 1. And here, 1 ANDed with 1 is 1. So therefore, we can put a 1 here. Now for the next row, 0 and 1. We're going to have 0 AND with 1, and again, with a 0 naught, but this time with a 1 naught. Now, I'm going to do a little shortcut here. I'm just going to go ahead and I'm going to write out this on the outside first. So I turn this 1 naught into a 0, and as you can see, we have this whole thing here, and it's multiplied, ANDed with 0. Well, anything ANDed with 0, here's our anything, that's on the left here. So we've got 1, we got 2 places, and 1, 2, we're at 0, and both of them are 0. Therefore, we can just say that this is equal to 0. Now, we have 1, 0, so this is going to be 1 times 0 plus this is going to be a 1 naught times 0 naught. Well, again, we've got a 0 here because 1 AND with 0 is going to be a 0, and that's going to be OR with a 0, and that's going to be ANDed with a 1. Well, this here on the left, this is just going to be 0 and with 1 because nothing is true here, therefore the OR is false, and we're going to get a 0. Finally, for 1, 1, we have 1 times 1 ORed with 1 naught, ANDed with a 1 naught. Well, I'm going to do that same trick that we did last time, to where I took this 1 and I plugged the 0 in. And here we can see, because we're ANDing anything with 0, that's just going to equal to 0. Therefore, this is only true in one place. Pretty neat. That's the truth table that we got. Now let's look at G. And this is going to be 3 inputs. And for 3 inputs, you're going to have 2 times 2 times 2. That's going to be 8 possibilities. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now, if you notice, this is just counting up in binary. So whenever you're making your truth tables, just count up in binary and you'll get the proper order. Now, let's look at G. So if we have 0, 0, 0, I'm going to plug all this in actually, all at the same time. So I wrote it on the left, but you guys can follow along on the right. So if I take this 0 in and I plug it here, well, that's going to be a 0 because anything in with 0 is 0. Next, if I plug a 1 in, that becomes true. So now it's dependent on this on the inside. Well, either A and B can be true, which is not. A and B are 0 here, or this can be true. And we have B not C. Well, we have B is equal to 0, and C is equal to 1. Therefore, we'll have B not C is equal to 0 not times 1, which is 1 times 1, which is 1. And that's true. So now we've got 0 plus 1 times 1. And that's equal to 1 because 0 OR with 1 is 1, ANDed with 1 is also 1. Therefore, this is a 1. Now, 0, 1, 0. Well, we know that this C here, because C is on the outside, right there, that's a 0, and that's going to make the whole thing false. That's a 0. And I'm actually going to go through and I'm going to fill out a 0 for everywhere else where C is false. Now, we got 0, 1, 1. Well, we have A here and a B here. Well, A is false still, so that term's not going to be true, because if you're adding them together, if there's a false, it's going to be a false. So if we just look at this B naught C here, so B naught C, well, we have B is true and C is true, therefore B naught C is going to be false, because you're going to have 0 naught times 1, no, sorry, 1 naught times 1, and that's going to be 0 times 1, which is 0. So that's going to be a 0. Now we have, on this next one, we have 1, 0, 1. So again, this first term is going to be false. And this second term, that's going to be a true. Because if you notice here, for this 0, 1 here, that was true. So I can just write, that's true. Now finally, this 1, 1, 1, that's finally where A and B is true, because A is equal to 1 and B is equal to 1. Therefore, AB is going to be 1 times 1, which is 1. And because C is equal to 1, well, it's all equal to 1. Well, hopefully that was enough of an introduction for you guys to know how to do Boolean algebra and how to plug things in and figure out truth tables. I hope you guys have a great day. See you in the next video.